Hi, this is Chris Kiefer, and welcome to the Power of ERDC. Today, we discuss an effort that is building robotic capabilities for combat engineers. ERDC's Robotics for Engineer Operations, or REO, program allows soldiers to perform high-risk tasks such as clearing mines, opening lanes, and digging defensive positions without exposing themselves to danger. Joining us is Dr. Ahmet Soylemezoglu, Systems Engineer for ERDC's Construction Engineering Research Laboratory, or CERL, and REO Project Lead. Ahmet, hey, it's great to have you today.
Hey, good morning, Chris. Thanks for having me.
Yeah, absolutely. Thanks for joining us. I guess let's kind of first start the high level and explaining what REO is. Can you talk about the basic concept behind REO and how it began and how it's kind of evolved from that point?
Absolutely. At its heart, the main concept for VO is developing capabilities to keep our soldiers safe. In this case, we are primarily focusing on combat engineers, as you stated. By definition, combat engineering is a very dangerous job. Those folks are in charge of clearing minefields, building bridges, preparing defensive positions, etc. In summary, we're in charge of assuring that we support the maneuver force. So as you can imagine, it is a very dangerous task, and the combat engineers are usually the first folks that have contact with the enemy. Okay, so VO strives to develop unmanned robotic capabilities so that our combat engineers can do their jobs from a standoff distance. We started this effort in about 2017, 2018 timeframe when the then Army Futures Command got stood up. And they decided to focus on a lot of robotic capabilities for the maneuver force. Think about robotic combat vehicles, robotic tanks, etc. And we found ourselves in a position where the support elements, such as the engineers, would be in a situation where we would have to go and help those robots out with human power.
Yeah.
So,
So if humans helping the robot, so you kind of lose some of the effectiveness.
exactly. Exposing soldiers to unnecessary risk. What we decided to do then, just to keep pace with the rest of the Army, we started an R&D program where we develop robotic capabilities for the combat engineers. So this initially started with what we call teleoperation, get the soldier out of the harm's way immediately and allow them to perform their mission from a standoff distance, using what would look like gaming controllers, looking at a video screen. And then we had been gradually increasing our capabilities to go more towards autonomy.
Sure. I think there's two thrust areas that you guys have, understanding and shaping. Is that correct? And can you kind of walk through that?
Absolutely. To be able to successfully execute combat engineering missions robotically, we have to have a really good understanding of the battlefield, of the environment. So in a lot of cases, during your mission planning phase, you'll get a lot of intelligence. This will include, geospatial imagery sets, threat assessment, et cetera. But you can never replace what we call the ground truth. So, that information that you received might have been weeks, days, months old. And when you show up to the actual mission area, things might have changed. The weather might be different. So we decided to come up with a fully autonomous capability where we can build small, highly maneuverable robots that can go and navigate the terrain and collect that battlefield intelligence. And while at the same time, doing near real-time mapping, we're interested in things such as, the terrain characteristics, obstacles, things like change detection. So, hey, this route looked this way 2 days ago. However, I am now detecting a disturbance on the soil, et cetera, et cetera. So the whole idea is bringing all this ground truth, most recent information, collected safely to the decision maker so that we understand where we're about to go. And we had a meet to plan the mission for robotic execution. Okay. So that's one part of the research area. So the other part is shaping the environment, shaping the terrain, right? So once we have that understanding, depending on the mission type, VIO has been developing capabilities to help with the shaping side. This could look anywhere, anything such as, clearing a minefield robotically and going and clearing a lane where the combat vehicles pass through after we clean that minefield. Robotically digging, fighting positions, etc. All done from a safe stand-up distance and with increasing automation and autonomy.
Yeah, I want to kind of pull more on that thread of how this effort evolved. And you talked earlier about going from, it started with teleoperating. And so in that case, you're kind of working with bulldozers and different heavy equipment from a safe distance, like you said, with a remote control. And then I knew you were doing that for a few years. And then I know it's gone into autonomy and then further autonomy. Kind of walk us through a little bit more of that and what that's looked like.
Yeah, absolutely. So you're correct. We started with teleop, and the driving force behind that was the state of the art in the technology when we started. For this teleop, okay, and teleoperation gives us that immediate standoff clearance. That allows us to take the soldier out of the harm's way immediately. So we started with incrementally increasing the distance where we can teleoperate from. When we started, the standard commercially available capabilities were limited to about 100, 150 meters. We pushed that all the way to about 7 kilometers, which corresponds to about 5 miles or so, give or take. And as we kept developing this capability, we started adding additional, what we call operator assist, soldier assist type of features to the teleoperation capability. So, instead of just looking at a static video feed of a vehicle, we started adding, horizon indicators, roll pitch indicators, etc. So that when we remove the soldier from the actual platform itself, you're losing a lot of the input that an actual operator uses, right? Yeah, so if you ask a bulldozer operator, they usually are listening to the pitch of the engine, the vibrations you're receiving, and how your machine is tilting back and forth. You put them in front of a video screen, all of that is gone. And how do we keep its effectiveness, mission effectiveness, while we perform the same type of tasks? So those are the type of things that we kept on developing. But we also realized really quickly, teleoperation is a very bandwidth intensive action. But what I mean by that is usually when we're doing these missions, we're limited to a tactical radio network. Okay, so we cannot rely on high-speed internet available all across the battlefield, et cetera, et cetera. So we're on a tactical radio network, sharing that bandwidth with all the rest of the soldiers that are out there. Teleoperation is very bandwidth intensive, meaning we're trying to push multiple camera views and those control signals through the same network. And as we increase the distance, the delays in that signal becomes a problem. So you end up chasing what we call chasing your control input. I'll give you an example. I'm on my bulldozer to engage its blade and move forward. I push my stick. I'm looking at my camera video. I cannot see anything happening because there's a delay from where I am going all the way to the machine. So I push my stick a little bit further, thinking that it didn't take. Then all of a sudden you find yourself in situations where you start losing control. Okay. The way to overcome this is building the intelligence on the platforms themselves. Instead of relying on the operator being in control all the time, can we program, develop algorithms, control schemes, etc., so that we can just hit go on the platform itself and it performs its mission on its own without us having to intervene. And if there's ever a problem, it calls back home and say, "Hey, I'm stuck. Help me out."
Yeah.
That's kind of how we started. And as you stated, teleop was the first phase. We are now currently working on building what we call those autonomous capabilities. Okay, so we take an approach of building what we call a library of behaviors. So when I say behavior, think of small, simpler, repeatable tasks that I can combine to perform a larger task. So this can look something like move forward and, engage blade 400 meters straight. Okay, so that would be one chunk, one behavior. And then, backing up would be another behavior, so that you can combine these smaller building blocks into more complex tasks that the machine can perform on its own. This is what we have been developing. And any questions, anything you need me to qualify so far?
Well, I was going to ask, so obviously when you're talking about autonomy, in this case, you're talking about autonomy in a battlefield. So it's a lot different than a self-driving car. Talk about the kind of just those challenges and overcoming that.
Absolutely. That's actually a great question. So, a lot of us have seen how the autonomy field is progressing, especially in the civilian world. Self-driving cars, you can go to Austin now and get in a driverless taxi, and if you had the courage for it, it feels really uneasy to sit in the back seat of a car with no driver. But you can go to the location that you want to go to without ever interacting with a human, etc. But what makes it different, or I should say a lot more challenging for the Army, is the environment that we work in. Okay, a lot of the commercial autonomy relies really, really heavily on existing infrastructure and assured positioning. So a strong GPS signal, for folks that are listening that are not familiar with what that means, as well as a lot of what we call a priori information about the area that we're going to be operating in. Okay, so that taxi that's driving in Austin has a really, really, really detailed map of the entire environment, right? And it has a really strong connection to a GPS receiver, and it's augmented by the additional onboard sensors on the car itself. Okay, now let's take a look at the Army side. We have a vague idea most of the times about the area that we're going into. We kind of have the location, but tactical situation will change where we'll actually be on the ground. Okay. We cannot rely on existing roads, street signs, etc. We're going to be in a challenging terrain. And on top of that, bad guys are either jamming the positioning signal or spoofing it, basically making it jumbled so that we cannot use it. And now we're asking a robot to exist in this environment and, find its way around and perform a really complex task. So I would say the Army's robotics challenge is on the same level of difficulty. What I would compare it to is what NASA is trying to do in Mars or in other planets or the moon. If you think about it,
Sure.
Pretty similar problem set, right? So
Yeah.
I want to put a rover on Mars. I don't have GPS. It's a very challenging terrain, and things are changing on the fly. Maybe the aliens aren't shooting at us, but on the Army case, bad guys don't want us there, so they're actively resisting.
Yeah.
So hopefully that kind of explains some of the challenges we're dealing with.
Yeah, I want to talk about the team you have, and it's a pretty a broad team. I know you kind of do work across a collaboration, I should say, across most of ERDC 7 laboratories, and that's a lot of skill sets and disciplines. Tell us about that and kind of what they all bring to the effort.
Absolutely. So I'll start with the beginnings of the project. So we was a concept, that went through the stage gates of becoming a full. So when we initially started this, we were about 5 or 6 people here at ERDC with a good idea and the appropriate background, I would say. So my background is in industrial automation, industrial robotics. A lot of my PhD work was done there. And I also bring the systems engineering perspective of being able to understand a really complex problem and trying to decompose it into its subcomponents to execute the research. So 5 or 6 people, mostly from engineering backgrounds, mechanical engineers, systems engineers, etc. We started the program, started understanding the challenges that I just talked to you about, and quickly realized that this has to be a really multidisciplinary, diverse team of folks that need to work on it. So slowly the team started growing, bringing in additional disciplines, computer science, computer engineers, electrics, electronics engineers, etc., all the way to the point, at some point, we had a geographer on the team, helping us understand, earlier on we talked about understanding the environment, right? Mapping the environment, etc. We looked at the team, we said, we really don't know how to consume geospatial maps or manipulate them. So let's go find the talent across ERDC and, bring that talent in to help out the team. So at one point, just like you said, we had almost all of the ERDC labs covered. That number, waxes and wanes depending on the current mission and the funding levels, etc. Grew up to about 50 people, a couple of years ago. This year, I think we're operating with about 30 folks, again, across the ERDC enterprise, and everybody brings their own domain expertise. And, it's kind of my job and my team's job to weave all that expertise into the challenges that we're experiencing in robotics.
Yeah, I guess we like to talk about the Power of ERDC. I guess it's the name of this program even. But when we say that, we kind of just mean the ability to bring the expertise of all these different labs together, kind of the whole is greater than the sum of the parts sort of thing. I mean, you all really do experience that, and you can just talk about what it brings to the project, being able to have again, experts from all these different laboratories. I would imagine, like you said, you need the geographer. You don't have to go, outside the organization to find one. It's a simple email, I guess, to a colleague away. I mean, how has that helped?
Absolutely. So the challenge of field robotics brings that requirement for a team of diverse backgrounds, right? So we already covered the geography and mapping. I'll give you another example. We at some point we were developing a control algorithm for a bulldozer blade, and it was not behaving the way we thought it was going to behave. So we were doing a lot of simulation work, and then we took it out to the field, and the results were not there. So we said, okay, there's something missing here. What are we missing? We need to go back to the actual core of the problem set. And it ended up being we were making a lot of assumptions for the type of soil that we were working with, and we didn't quite understand the soil mechanics, right? So normally in some of the other Army R&D labs, etc., this would be a big challenge because you would not have that knowledge in-house, and you would have to find an either academic partner or, go out to contract with industry, etc. We said, hey, ERDC is full of soil mechanics folks. Let's dial up GSL. And, they have a whole branch that do mobility calculations. And, let's have some conversations and see if they can solve this problem, first of all, and then if they have the capacity, to join the team. So lo and behold, the Power of ERDC pretty much all the expertise that we want in a lot of the fields are already working at ERDC. And um, it's just about having the knowledge about everything around you and making those connections and, forming that big team.
Yeah, yeah, that's great. And I guess the other thing we like to talk about at ERDC is just kind of how the synergy of civil works and military, and you can take something learned from one and apply it to the other, which is, I guess, in some ways what you're able to do with the flow mechanics stuff. So that's cool to see. On the theme of partnerships, I know you all are also working a lot with industry, and academic partners as well. But talk about that more, and especially, I know the industry partnerships are a big part of this.
Yeah, absolutely, Chris. Uh, Even though ERDC is really powerful, we have a really, really strong team. Robotics is a field that's advancing really, really, really quickly. So, early on, from the start, we realized that, yes, we have an amazing team here, but we still need to partner with other folks. So the natural thought process is, looking at the industry and see who the big names in industry are working in this field, or for our case, particularly for the heavy construction equipment, names such as Caterpillar, John Deere, Komatsu, et cetera, come to mind. So we started making those connections early on. And in about 2019 or so, we were able to establish a collaborative research and development agreement with Caterpillar. Okay. That allowed us access into what Caterpillar had already figured out, spending the last 100 years building construction machines, right? So we started collaborating with Caterpillar engineers, and at some point, we were given access to some of their construction equipment that were not commercially available yet. So this is one way to, jointly enhance capabilities, helping both the industry as well as the Army, and significantly accelerate efforts. Okay. So that partnership continues to this day. We also established a collaborative research and development agreement with Trimble Systems. You may or may not be familiar with Trimble, but Trimble is the world leader in surveying type of equipment, and Army uses their equipment in their training and their mission sets. So with Trimble, we were able to take what they use with the Army for just basic surveying and turn that into a localization capability that I'm not getting into the details here, but that's just another example with industry. And the other part of this is academia, right? So that's where we developed a lot of the knowledge, especially in basic research and some of the earlier applied research side of the house. So we have really strong collaborations with University of Illinois at Urbana-Champaign, being practically on their campus, and that it's in our backyard. I would say about 60% of the workforce here at Seoul is UIUC, University of Mississippi, University of Michigan. Just making those connections with the world leaders in academia and working through either broad agency announcements or other types of collaborations with those folks, so that we can keep pace with the rest of the knowledge. That's how we built those partnerships and relationships. So if I try to characterize this, the industrial partners, the focus with them is the next 2 to 5 years, more applied. What can we get to the field soon? And, a lot of the academia engagements are even further forward leaning. So, let's get in from the basic research side of the problem set, so that we are ready for that broader horizon of 5 to 10 years or so.
Yeah, sure. Another topic I want to ask you about, that I know you all have done pretty extensively, is field testing. I know you've had a lot of experience of taking some of these technologies that you all have worked with, bringing them to different soldier demonstrations and having them actually use them. Tell us a little bit about that, some of the places you've gone, but also what you've learned from the soldiers and how that's kind of helped improve what you're working on.
Absolutely. That is a great question. I think having field experiments, having that soldier feedback is crucial in all of the capabilities we're developing in RBEC, right? So you can approach this in an isolated manner where you just put your head down, work on your project for 4 years, and when you're done, try to find somebody to use it. Or you can do what we try to do and get involved in soldier-led experiments or stage gates, as we like to call them, at each year. So what we do with robotics for engineer operations, or a lot of the other robotics work at ERDC, is to participate in those soldier-led broader Army experiments exercises every year, so that we get that crucial feedback. So the way this works, Chris, is we will have a 4-year development plan with different milestones and capabilities, right? So we share that development plan with our stakeholders, okay? Usually sometime between May or June, July timeframe at each fiscal year. We will sign up for a big experiment, such as the project convergence that takes place at the National Training Center at Fort Irwin, or the Maneuver Support Center of Excellence's NISPEX experimentation at Fort Leonard Wood, etc. So we freeze our development. We go to these locations and we get assigned an actual active duty unit that comprises of combat engineers. Okay, we get about a week or so to do what we call new equipment training with these soldiers. So we show up, we take our robots, we take our team, we sit down with the soldiers. There's some classroom instruction as well as hands-on instruction, okay, on the robots themselves. And then these folks are assigned a certain mission to execute, okay? So, mission can be anything such as, go perform engineer reconnaissance in this area, and then build me soldier fighting positions at this, and this location, okay? So they get to mission briefing, they get to training, and then we take a step back. They have our equipment as their own organic capability. It's their own organic capability, and they go and perform the mission to the best of their ability, okay? So this allows us to see how well our technology will transition to these folks in the future. And then this quickly allows us to see the capability gaps that we either haven't thought about or things that we have to strengthen, etc. It becomes a really, really valuable feedback coming directly from the future end users that's going to use this technology. So we do this on a repeated basis almost every year.
Yeah, sure. We talked earlier about kind of that synergy, again, at ERDC between civil works and military. And I know you've even partnered a lot with Anton Nechev, who's done Dambot, which was a previous episode on the podcast. I don't remember the number. If people would find it on our website, maybe 8, 10, somewhere in that range. But talk about, for Rio, are there civil works, emergency operations applications for some of the technologies that you all are working on?
Absolutely. So field robotics is field robotics, right? So, being able to develop unmanned robotic capabilities in challenging environments. So the civil works side of the house has its own terrain and infrastructure related challenges that look very similar to the Army side, okay? One good example is disaster relief, emergency response. Think of a situation where a hurricane just went through, Mississippi, and all of your road networks are covered with debris, and, your power is down. Sorry about that.
Time to tell what. I thought you did that on purpose.
Your roads are covered. You need to get folks to the hospital. You need to bring the power back on, but the hurricane is still continuing, right? So wouldn't it be amazing if you had unmanned capabilities that can go out there as soon as that hurricane hits and start clearing that debris, etc. So The bulldozer that does the lane proofing after clearing a minefield would be perfectly capable of doing the same thing, when we're doing debris removal and emergency response. So I could expand on the applications, a lot more. There are many more examples. Let's take, for example, infrastructure inspection, right? So we're talking about going into locks, gates, dams as part of the civil works mission, which is a very dangerous job for those inspectors. You have to either stop the entire traffic or stop operations to be able to go to this inspection. The capability that we develop for understanding the environment, understanding the terrain on the military side, fully autonomous robot being able to operate on its own, map things at high detail, etc., and bring it back home as a direct application on the civil works side. Put that same robot in a conduit in a dam, and you get similar results. So I'd like to highlight the fact that we don't look at ourselves here at Robotics for Engineer Operations as the military robotics team. We take the approach of one ERDC robotics team across all the domains, all the laboratories, etc. There are a lot of examples where team members from BO are working on a project with CHL doing, mapping on littoral zones or riverine mapping, and those skill sets transfer across all these domains.
Sure. The last thing I want to just ask about is kind of what's next and kind of what does the future hold for this? I know you talked previously, there's some AI components that you are applying as well and so forth. Just kind of tell us about what's on the cutting edge now.
Yeah, absolutely. So the future for VIO specifically is moving towards what we call multi-machine teaming, okay? We didn't get into a lot of specific examples in this talk, but what we have been able to develop so far requires a one-to-one connection between an operator, a soldier, and the robotic platform itself, okay? We have increasing levels of autonomy on the robotic platform. The bulldozer can clear a lane, build a berm on its own, etc. But I always have one soldier watching that machine for mission effectiveness and helping it out. What we need to get to increase mission effectiveness and achieve what we call force multiplication is to allow that one soldier to control multiple machines to do the same job, okay? So why watch a single robot do this thing where I can send a team of robots working a lot more faster and in a collaborative manner to, perform that complex task. That's where Rio is going towards. So last year at Fort Leonard Wood, we tested out the first step towards this, where we had a fully autonomous skid steer building a berm on its own. Soldier looked at his screen, said, "Hey, this is where I want to build this berm." Hit go, and he turned around to the other screen and took control of a teleoperated skid steer to prepare the material for the other one and do additional tasks on the side. So if you break that one-to-one tie and go one-to-many is where we're going to start seeing a lot of the benefits for robotics. In terms of keeping up with AI, artificial intelligence, machine learning, etc., so far we have been relying on classical control theory, etc., to develop the control algorithms for a lot of the autonomous behaviors on our platforms. But this new field of artificial intelligence, there are some models called visual language action models, okay? Not getting into the too deep technical details. We have ways to teach behaviors to a robot by observing previously collected data from other environments, other operators, etc., and then slowly tying that to what we call reinforcement learning. So basically telling your robot, "Hey, you've done a good job. Here's a reward. No, you've done a bad job. there is a punishment, and iterating through these in an automated way to come up with emerging behaviors. So this could look something like us instrumenting a bulldozer with different sensors, cameras, joystick inputs, etc. Putting an experienced operator in that bulldozer and collecting data for X amount of hours or episodes. Okay, and then using that data set to slowly build other behaviors by changing the environment that normally, traditionally, that data set would apply just to that environment, right? And this is what makes building autonomy really hard. So the capability that you have developed only applies to, the soil type of loam. When it's dry, there's no moisture. And then, we're in Fort Maneuver. Mm-hmm. If I take that autonomous behavior, put it into the, swamps of Mississippi in a densely forested area, it will not perform well. So these visual language action models actually allows us to adapt that autonomous behavior without actually having to come down to Mississippi and collect all that additional set of data and, build the capability that way. So we think this is going to accelerate capability development and an awful lot. I don't want to give a number, but it's going to be multiples of where we are right now. And then it's really exciting. And that effort is going to be supported by the High Performance Computing Center down at ITL, because it's very computationally intensive, but there are a lot of early encouraging results that we're observing. So that's where we're going to push our research efforts into in the future.
Yeah, that's fantastic. Is there anything that I didn't cover that you want to be sure to mention before we wrap this up?
No, I think we covered most of what I wanted to talk about. I would love people to reach out if they have any questions or if they're interested in this field. Robotics field is inherently we have a lot of turnover in terms of researcher availability, etc. So if this is a field that anybody listening to this podcast is interested in, we would be really happy to talk to you, work with you over a short period of time during the summer at SETMA, see if there is mutual interest, and then, keep growing our team.
Yeah.
And don't hesitate to out to me.
That's perfect. I was just going to say, for people who want to reach out, there's an email address we've kind of have set up for various inquiries in ERDC. It's erdicinfo@usace.army.mil. We will have that in our show notes, so you don't have to have it memorized. But again, that's erdicinfo@usace.army.mil. And if you send that, someone will get it to Ahmet and help you out on that. So thanks. That concludes our show for today. Thanks to everyone for joining us. Ahmet, thank you so much for your time.
Hey, Chris, thank you very much for having me. I hope this was informative. And if you put me on the spot, I can talk about robotics for 2 days nonstop. So thank you for driving the show, and have a great day.
Yeah, absolutely. Thanks. And I think this was a great discussion. So appreciate all the work that you and your team are doing, and important work, like you said, keeping the soldier safe, and that's what it's all about. So thanks for your efforts. To our audience, I remind you can go to our website, poweroferdicpodcast.org. A whole bunch of resources, including resources for each of our episodes. We'll have some photos from Rio on the website. We'll have a video of this interview with the audio podcast of the interview. Follow ERDC on LinkedIn. That's also where you can find the video of this episode. So thanks again to everyone, and we will see you next time.
Thank you.